Today's video lesson is on forming ionic compounds using the charges from cations and anions. So we're going to do a quick little review here, and then we're going to get into forming compounds. The objectives for today are that you will be able to form compounds using charges, you will be able to name ionic compounds, and you'll be able to use polyatomic ions involved in ionic compounds. To begin with, ionic compounds are formed from ions of metals and nonmetals. Some examples of ionic compounds include sodium chloride or magnesium bromide. Other examples include iron oxide, which is more commonly known as rust. What you'll notice about each of those compounds is that they have a metal, in this case the sodium, the magnesium, and the iron. And then they have a nonmetal, which would be our chlorine, our bromine, and our oxygen. If you do not have a metal or a nonmetal, you're not dealing with an ionic compound. Now, as far as ions go, cations and anions make up an ionic compound. Cations are metals, for the most part, and they have a positive charge to them. Anions, on the other hand, are nonmetals, and they have a negative charge to them. What we are looking for is, in the formation of cations, is you can take any metal, and what we want to do is we want to determine the valence electrons, and we want to get this to 0. So how many electrons do we have to give up to get to 0? And whatever you give up, that's what your charge is going to be. So let's look at an example here. Calcium, for example, is Ca, and it has 2 valence electrons. Okay, and because calcium's close to 0, what we're going to do is we're going to give up those 2 electrons, and so that's going to give it a positive 2 charge. Another way to look at this is that you can set up a subtraction, and we're going to do 2 valence electrons minus whether we're closer to 0 or closer to 8, and closer to 8 will make sense here in a second, so minus 0, and that leaves us with a positive 2. So the cation of calcium is a positive 2. Aluminum, being Al, has 3 valence electrons. And because it is also closer to 0, we're going to set up our subtraction problem, 3 minus 0 here, and that leaves me with a positive 3. So aluminum's cation is a positive 3 charge. Anions, on the other hand, want to get to 8 valence electrons. And so they're going to gain electrons to do that. And they're going to end up with a negative charge. And what this looks like here is, in our example of oxygen, is oxygen has 6 valence electrons. And with having 6 valence electrons, it's closer to 8. So remember before with cations, we subtracted 0 to get to 0. In this case, we're going to subtract 8, and that's going to tell us what our charge is. So 6 minus 8 leaves me with a negative 2. And if you look at that, oxygen also has to gain 2 valence electrons to get to 8. Each electron has a negative charge, so it's a negative 2. So oxygen, as an anion, is negative 2. Bromine, on the other hand, Br, has 7 valence electrons. Okay? And again, we're going to set up our subtraction problem here because it's closer to 8. We're going to subtract 8, and that leaves me with a negative 1. And so bromine, as an anion, becomes a negative 1. So what does this all mean? Why do I care about the charges? When you form ionic compounds, you're dealing with cations and anions, and each of those have charges, but the overall ionic compound has a charge of 0. And so we're going to balance this out to 0 by adding cations and anions. And then when we want to name them, though, we're going to take the name of the metal first, and then we're going to put the name of the nonmetal at the end, or we're going to do a polyatomic ion. So if I take, for example, aluminum and chlorine. So we've got aluminum, which we already established has 3 valence electrons. And we've got chlorine, which has 7 valence electrons. Okay. And remember, valence electrons can be determined by whatever column it is in on the periodic table. So aluminum we have a 3 minus 0 because it's closer to 8. And so that gives me a plus 3 for aluminum. Chlorine, on the other hand, is closer to 8, so we're going to subtract 8, and it leaves it with a negative 1. So the anion of chlorine is negative 1. Now, if I want this to balance out to 0, I've got plus 3 from my aluminum, if I have one atom of that. If I have one atom of chlorine, I'm going to subtract 1. And that leaves me with a positive 2. But we have to get this equal to 0. So I can either add more aluminum or more chlorine. Since I would need to continue to decrease my positive charge, I'm going to add more chlorine. And in this case, I'm going to add 2 more. And if you look at this, we've got plus 3 minus 1 minus 1 minus 1. So 3 minus 3, that's going to equal 0. So the last part here is we have to do our formula. And I've got 1 plus 3, so that's 1 aluminum. And then I've got 3 minus 1, so that is 3 chlorine. So it's AlCl3. Now naming it, we've got aluminum. And then I'm going to change the ending on chlorine to an IDE, so it's going to become chloride. We're going to do more with that here in a second. Another example, and this is dealing with the polyatomic ions now, is we've got magnesium, which if you establish what the charge is on, it's going to be a plus 2. And we've got nitrate. Now nitrate is not one that comes from the periodic table. This is your anion here. If we're dealing with something from the periodic table, it may end in an IDE, but if it ends in something else than that, go to page 230. In fact, I'd recommend you start by looking on page 230 when you're doing these. So if we look on page 230, nitrate is actually NO3 with a minus 1 charge. Okay, it tells you what the charge is going to be. So we've got plus 2. We've got a minus 1. We're trying to get to 0, so I'm going to subtract another 1, and that equals 0. So I've got Mg, and then I've got NO3, but I need 2 of these. And if I just write a 2 up after that, it looks like NO32. That's not right. We want to put it in parentheses and use the distributive properties there, so it's now 2 times NO3 and 1 magnesium. And so our name becomes magnesium nitrate. I hope this video here today helps in reviewing formation of ionic compounds using charges. Remember, look on page 230, see if it's there first, and then go to the periodic table. There will be additional videos up for the rest of this week to help you out.